In this video, we're going to talk a little bit about central and inscribed angles and some of the algebra type problems that you can come up with when you're dealing with central and inscribed angles. So the first thing to remember is what a central angle is, what an inscribed angle is. Well, a central angle is when you have an angle and the vertex of that angle, or the corner of that angle, is touching the center of my circle. An inscribed angle, it's when the vertex of the angle is touching the edge of the circle and the other two legs of my angle eventually hit the circle on an edge somewhere. So in number 3, this is an inscribed angle. This one is an inscribed angle. Number 1 here is an inscribed angle because it's touching the edge of the circle and the two legs are eventually touching the edge of the circle. So this is also an inscribed angle. This one over here, number 4, the vertex is directly in the center. So this is a central angle. And then this one over here, it's neither. It's not inscribed because the vertex is not touching the edge, and the vertex is also not directly in the center. Now, before we go on to some practice problems, I want to mention something about the measurements of central and inscribed angles. So we're going to look at number 6. Although normally it wants us to find this, I want to use this because it's going exactly halfway across the circle. Well, we know that, first of all, I see XWV, I see this inscribed angle over here. I also see a central angle, maybe I'll name this point O. I also see angle XOV, which is a central angle. Now I know if an angle makes a straight line that it measures 180 degrees. And I'm going to zoom in on this guy a little bit. We're going to focus on it. We should also know that all the way around the circle is 360 degrees. So it would go to say that halfway around a circle, like I see here, is 180 degrees. Well, what that tells us is that the measure of my central angle is exactly equal to the arc that it intercepts. So every angle inside of a circle is going to intercept an arc. In this case, both of my angles, XWV and XOV, they both intercept this arc, and that's arc XV, which I know is 180. If it's a central angle, we already saw that it is exactly equal to the arc that I'm intersecting, or intercepting. Now, let's take a look at what the measure of the inscribed angle is, and I'm going to zoom out a little bit here. I'm going to use a protractor here, and I'm going to measure it out. I'm going to put that on the center. Make sure that it lines up. So this is too far. I want to line it up with the leg of my angle. And you can see, if I bring the paper down a little bit, you can see that the measure of my inscribed angle here is exactly half of the 180. My inscribed angle is measuring 90 degrees. So here I'm going to say that the measure of angle XWV is a right angle, which is 90 degrees. This is the big rule. This is the real big rule that we see between central and inscribed angles, is that my central angle is equal to the arc that I intercept, while my inscribed angle is 1/2 of the arc. Similarly, I can say, well, I have an inscribed angle. I can multiply by 2 to get the arc, and that also tells me what the central angle is. So maybe I'll just write that out so you can kind of digest that a little bit. So central angle equals the arc, where an inscribed angle is equal to 1/2 times the arc. So let's take a look at this first example. We actually just found out that this angle here is 90. I know that this angle WXV, they give us that angle is 42. And they want to know, well, what's the measure of arc WV? From what we saw before, my inscribed angle is half of the arc that it hits. So here the arc was 180 and my inscribed angle was 90. I'm just doing it the opposite way now. My inscribed angle is 42, so I'm going to need to multiply by 2 to figure out what my arc will be. So I can do 42 times 2, which will be 84. Easy as that. Let's take a look at a couple more examples. Maybe I'll stay zoomed in as much as this. So I see that arc BC is 80 degrees. Well, I want to find the measure of angle BAC. And since BAC intercepts or hits this whole arc over here, which is 80, I know that the measure of my inscribed angle is half of the arc that it hits. So if this is 80, that means that this over here is 40. Let's do a couple more and see how we can go. This one starts to get a little more complicated, number 8 on the sheet. So I've got 49 for this arc, for this angle. Which intercepts arc BC. Then they gave me 70 for angle C, and that intercepts arc DB. Well, that's unfortunate because they wanted me to find this over here. There's just a couple pieces of information that you need to put together and you should be able to find it. Well, this is an inscribed angle, it's 70, so that means I can multiply by 2 to find my arc because my inscribed angle is 1/2 of my arc. So 70 times 2, that means that this will be 70 times 2, which is 140 degrees for my blue arc. I can do the same thing over here. 49 hits this arc BC, so that means that this is going to be almost 100. Take away 2 of those, so it's going to be 98 is this red arc because I took 49 times 2. Well, now I've got 140 going this way, 98 going this way, and I know all the way around the circle has to be equal to 360, and I'll use that fact to find my last missing arc. I know that my 140 plus the 98 should equal, plus my missing arc, that should all add up to equal 360 because all the way around a circle should be 360. Well, 140, where'd my camera go? Well, 140 plus 98 gets me 238. If you don't believe me, I don't know if I believe me. Let's check the calculator just to be sure. So 140 plus 98, 238 plus x, I'll change this question mark into an x, equals 360. Take away 238 from both sides, and x is equal to 360 minus my old answer, which was 238. And I found that that missing arc over there was 122, which is pretty cool because I didn't even have that inscribed angle over there. Oh, I see. Actually, I went about this problem in a very much more difficult way. A much easier way to do this problem would have been to say, hey, the angles in a triangle need to add up to 180. 49 and 70, I can add those up, take away from 180, find that, use the inscribed angle. Let's use that as a way to check. So I know that 49 plus 70 that's going to make 119. These three angles, the 49, 70, and I'll call this one y, these three should add up to make 180. So I can do 180 minus 119, which means this angle here, y, is 61. So I can multiply that inscribed angle times 2 to get 122. 61 times 2 is 122. It checks out either way. All right, let's take a look at maybe one more question, and then you guys have to work on the rest of this worksheet on your own. All right, let's do... This is a good one. I want to check this one out. All right. Here I have an inscribed angle. Angle EGF. And it hits this arc over here, arc EF. I know that arc EF is 192 and that my angle is 31x plus 3. Well, if it's an inscribed angle, I can just take 192, I can divide it by 2, and I'll find out what my inscribed angle is, because that's just the rule of inscribed angles. Remember, we saw that earlier in the video. Central angle, my central angle is equal to my arc. My inscribed angle is half of my arc. So I have an inscribed angle. It should be half of what this arc is. So I can do 192 divided by 2. 192 divided by 2. And I get 96. So I know that this angle is actually equal to 96. But if I want to find x, well, I just got to do the algebra now. If this angle is equal to 96, that means I can just set up that equation. 31x plus 3 should equal 96. Alternatively, we could have set this up originally as 31x plus 3 equals 192 divided by 2. But that's just, we skipped the first step here by doing it in the circle. And now I can just do this algebra. I'll take away 3 from both sides. 31x equals 93. So then I divide both sides by, divide both sides by 31. And I'm left with x is equal to 3. I can double check that if you guys want me to. 93 divided by 31. And we found that x was equal to 3. So I hope that helped with some basics on inscribed angles and how to do some algebra with them that you might end up seeing on the Regents exam.